Module 8. Drainage Systems and Wastewater Management. 1. Understanding drainage systems. Definition. A drainage system is a network of pipes, fittings, and fixtures that transports wastewater and stormwater away from buildings to treatment facilities or disposal points. Functions. Collection of wastewater from bathrooms, kitchens, laundry areas, and toilets, safe disposal of human waste and grey water, prevention of sewer gases entering living spaces, protection of public health and the environment. 2. Classification of drainage systems. Drainage systems are broadly divided into the following categories. Sanitary drainage systems, designed to carry human waste and grey water to a sewer line or septic tank. Consists of soil pipes, toilets, urinals, and waste pipes, sinks, baths, washing machines. Stormwater drainage systems handles rainwater runoff from roofs, pavements, and landscapes. Prevents flooding, soil erosion, and waterlogging. Combined drainage systems. A single system that collects both wastewater and stormwater. Economical but risky, may lead to overflow during heavy rain. Separate drainage systems. Wastewater and stormwater are carried in different sets of pipes. Safer, cleaner, and more efficient. 3. Key components of a drainage system soil stack. A vertical pipe carrying discharge from toilets and urinals. Waste stack. Carries water from sinks, baths, and washing machines. Vent pipes. Allow gases to escape and maintain atmospheric pressure in the system. Traps. Curved sections, U, S, P-shaped, holding water to block sewer gases. Cleanouts. Openings to access pipes for inspection and cleaning. Manholes. Underground chambers for maintenance and inspection. Grease traps. Capture fats, oils, and grease before they enter the sewer. 4th. Principles of good drainage design. Gravity flow. Most drainage systems rely on gravity. Pipes must be laid at proper slopes. Ventilation prevents siphoning of traps and allows gases to escape safely. Trap seal protection ensures water in traps is not lost through evaporation, siphoning, or back pressure. Hydraulic efficiency. Pipes must be sized to handle expected loads without blockage. Accessibility. Provision of cleanouts and manholes for easy maintenance. Backflow prevention. Devices and methods to prevent wastewater from flowing back into clean water lines. 5. Wastewater treatment and disposal methods. On-site treatment systems. Septic tanks. Common in rural areas. Uses anaerobic digestion and soil absorption. Soak-away pits. Absorb water into the soil. Centralized systems. Municipal sewage treatment plants. Primary, sedimentation, secondary, biological treatment, and tertiary, disinfection, filtration. Modern innovations. Grey water recycling. Reuse of bath/laundry water for irrigation. Biogas digesters. Convert sewage into usable methane gas. Eco-friendly drainage systems. Biofiltration, wetlands. 6. Common drainage problems and troubleshooting blockages due to grease, hair, food particles, or foreign objects. Solution. Mechanical cleaning, rods, augers, chemical cleaning, hydrojetting. Foul odors caused by dried traps or poor ventilation. Solution. Refill traps, repair vent pipes, check seals. Backflow. Sewer water flowing back into fixtures. Solution. Install check valves and backflow preventers. Leaks. Faulty joints, cracks, or corrosion. Solution. Repair or replace damaged sections. Slow drainage. Improper slope or partial blockage. Solution. Check slope, clean pipes. 7. Safety codes and standards plumbing codes. Ensure compliance with local building and sanitation laws. Health and safety. Proper PPE. Gloves, boots, goggles, respirators when handling wastewater. Environmental protection, preventing contamination of groundwater and surface water. 8. Practical skills. You will gain designing and sizing drainage systems, installing soil, waste, vent, and stormwater pipes, using pipe slope, measuring tools and levels, applying troubleshooting methods for common drainage issues, implementing eco-friendly drainage and wastewater recycling systems.